All right, 2.7, we're going to talk about sums, differences, products, and quotients of combination functions. So we're going to be adding, subtracting, multiplying, and dividing them. We're also going to be finding the domain of each. Notice how when we are adding, subtracting, and multiplying, our domains are the same. When we're dividing, we just have to make sure that whatever's in our denominator does not equal 0. So you can't have 0 in the denominator. So it'll be a similar domain, but we got to make sure that we include that whatever function is in the denominator, it can't be 0. So when we're finding our domains, just as a little refresher from when we did this in the beginning of chapter 2, if I have a fraction, what can I not have in the denominator? 0. So the denominator cannot equal 0. If I have a square root, what cannot be under the square root? I can take the square root of 0. What can I not take the square root of? Negative numbers, so it has to be greater than or equal to 0. And then putting those together, if I have a square root in the denominator, I would set this greater than 0, because it can't be equal to 0 in the denominator. Yeah, we're doing it again. If it's not one of these three things, you don't have any fractions, you don't have any square roots, what would our domain be? If it's not one of these three things, what would our domain be? All real numbers. In interval notation, how would we write that? Negative infinity to infinity. All right, so in example 1, in A, we have to find the functions f plus g, f minus g, f times g, and f divided by g, and their domains. So first, let's start with f plus g. So I'm just adding the two functions together. So we take f, which is 1 over x minus 2, and add it to the square root of x. I can't combine these together. I don't have any like terms. There's no distributing going on here, so we can just leave it like this. This is f plus g. Now let's find our domain. Our domain is the domain of both of them separately, and we just put them together. It's what overlaps, but we're going to put the domains together. So in the first one, I have a fraction. What did I say I can't have in a fraction? 0 where? In the denominator. So I'd set the denominator not equal to 0. So what can x not be equal to? 2. Awesome. So x cannot equal 2. In g, what can I not have under a square root? Negatives. So I'd set x greater than or equal to 0. So this part of the domain would be x is greater than or equal to 0. So for my domain here, I have x does not equal 2, and x has to be greater than or equal to 0. I'm going to put those on a number line just to help me see what my interval notation is going to be. On WebAssign, you have to answer them in interval notation. So let's put on a number line just to see. X cannot be 2, so I'd have a hole here at 2. And then x is greater than 0. So I'm talking about numbers that are equal to 0 and greater except 2. How would I say this in interval notation? Bracket. Bracket what? 0. And then it goes to what? To 2, because we have a hole at 2. So 2 gets parentheses. And then it starts back up again where? 2 to infinity. Awesome. So this would be our domain. Bless you. All right, let's find f minus g. So we have 1 over x minus 2 minus the square root of x. Again, I don't have any like terms here, so I don't need to simplify. I can't combine them together, so we can just leave it like this. What would our domain for this be? So what did I say on the last page? our domain for adding, subtracting, and multiplying are all going to be the same thing. So it's the same exact thing as our domain for adding. Any questions there? All right, let's multiply. F times G. So F is 1 over x minus 2 times the square root of x. So we can simplify this. If we're multiplying fractions, we just multiply straight across. So it'd be the square root of x over x minus 2. What would our domain of this one be? Perfect, the same domain. For adding, subtracting, and multiplying, your domains are always going to be the same thing. So adding, subtracting, and multiplying, all three of these domains are the same. We just have to be careful when dividing. Any questions so far? All right, let's divide them. So it's asking for f over g. So f over g. F is 1 over x minus 2 divided by g, which is the square root of x. I can't have a fraction in my fraction, so what do I need to do here? Keep, change, flip. So we keep the top, change to multiplication. I'm going to flip the bottom to be 1 over square root of x. So when I multiply these together, I multiply straight across. So it'll be 1 over the square root of x times x minus 2. You can distribute if you want to, but I think WebAssign would be okay with just leaving it like this. I'm okay with just leaving it like this. If they were like terms and you had a number to distribute, I would say distribute, but you could just leave it like this. Now our domain for dividing is going to be a little bit different. We have to make sure our denominator here does not equal 0. So I would set both pieces in my denominator not equal to 0. So the square root of x cannot equal 0, and x minus 2 cannot equal 0. But x has a square root, so we also have to keep in mind that it has to be greater than 0. Why is it not or equal to? Why is it not greater than or equal to? Because it's in the denominator. We can't have equal to 0 in the denominator. So my two restrictions on the domain would be x is greater than 0 and x does not equal 2. So how would I write that as a domain? It's going to be super similar to the last ones we did, but one little change. What's going to have a parentheses? The 0. The 0 is going to be a parentheses now because it's not including 0. Because it's just greater than 0. It's not equal to. So we have a parentheses 0 to 2, and then from 2 to infinity. All right, for B. B is asking us to find f plus g of 4, f minus g of 4, f times g of 4, and f divided by g of 4. So we can add our two functions together and then plug in 4, or I can plug in 4 into both of them and then just add the two answers together. So I'm going to do that. I'm going to plug in 4 into both my functions, find out what f of 4 is and g of 4, and then just add, subtract, multiply, and divide. So first let's find f, bless you, f of 4. So I'm going to plug 4 into my function. I have 1 over 4 minus 2. So that'd be 1 over 2. Now let's find g of 4. That would be the square root of 4, which is, what's the square root of 4? 2. So the first part in B is asking me to find f plus g of 4. So I'm just going to add these two together. I have 1/2 plus 2. If I'm adding a fraction and a whole number, what do I need? Common denominator. I can make it 2 over 1, which changes to 4 over 2 to give me a common denominator, so that would be 5 over 2. Any questions there? Next one's asking me for f minus g of 4. So I can take my two functions and subtract them. So f of 4 is 1/2 minus g of 4, which is 2. I'm subtracting again. I need a common denominator, so I'm going to change this to be 4 over 2. So 1 minus 4 would be negative 3 over 2. All right, so now when we multiply f times g of 4, that would be 1/2 times 2. What's 1/2 times 2? 1. Awesome. And then f over g of 4, so f divided by g, that would be 1/2 divided by 2. What do I do when I have a fraction and a fraction? Keep, change, flip. So we keep the top, change to multiplication, and flip the bottom. So I flip it to be 1/2. When I multiply straight across, I get 1 over 4. All right, on the next page, example 2. So here it's asking us to evaluate f plus g of negative 3. So we could either do it just like we did the last one where we plug it in separately and then add them together, or I can add the functions together and then plug it in. So I'm going to do it differently than I did on the last page. I'm going to add my two functions, then plug in negative 3. So I have negative 2x plus 3 plus, because it's telling me to add them, 1 over x plus 4. Now it wants to find f plus g of negative 3, so I'm going to plug in negative 3 into my x's. So negative 2 times negative 3 plus 3 plus 1 over negative 3 plus 4. So this turns into 6 plus 3. Negative 3 plus 4 would be what? 1. And what's 1 over 1? 1. So I have 6 plus 3 plus 1, which is 10. Any questions here? Let's do the next one. Be careful because the next one says g minus f. So we take our function g, that would be 1 over x plus 4, minus f, which is negative 2x plus 3. Before I plug in negative 1, I want to simplify this a little bit more. How could I simplify? Distribute the negative. So I have 1 over x plus 4 plus 2x minus 3. Now we can plug in negative 1 and solve. So 1 over negative 1 plus 4 plus 2 times negative 1 minus 3. So this would be 1/3 minus 2 minus 3. Tabit, what's negative 2 minus 3? Negative 5. Tabit, what do I need if I'm going to subtract a fraction and a whole number? A common denominator, so I can make it 5 over 1. What's my common denominator going to be? What do I need to do to 5 over 1 to give it a common denominator? Multiply by 3. So we change it to 15 over 3. 1 minus 15 is negative 14 over 3. All right, let's do f times g of 5. So I'm going to multiply my two functions together and then plug in 5. So I have negative 2x plus 3 times 1 over x plus 4. Now when we're multiplying, we can multiply straight across and just put that negative 2 plus 3 on top. So it'd be negative 2x plus 3 over x plus 4. If you're not super confident in your simplifying skills, just plug in 5 and simplify with the numbers. You can plug in 5 into each function individually and then multiply your two answers together. So I'm going to plug in 5. So negative 2 times 5 would be negative 10 plus 3. And 5 plus 4 is 9. So that would be negative 7 over 9. All right, last one, we have f divided by g. So I have f, which is negative 2x plus 3, divided by 1 over x plus 4. What do I do if I have a fraction and a fraction? Keep, change, flip. Keep the top, change to multiplication, and flip the bottom. X plus 4 over 1. So we multiply our numerators together. We get negative 2x plus 3 times x plus 4. Now you could FOIL to simplify, but that would just be more work than you need to do. We're just plugging in 2, so let's plug in 2 into the x's and follow PEMDAS. So make sure you do the parentheses first. So starting with our first parentheses, we have negative 2 times 2 would be negative 4. And negative 4 plus 3 is negative 1. Then we have 2 plus 4, which is 6. What's negative 1 times 6? Negative 6. Awesome. Again, if you wanted to, you can plug it in separately. Plug in, find f of 2 first, which would be negative 2 times 2 plus 3. So that would give us negative 1. Then find g of 2, be 1 over 6, and then divide them. F divided by g of 2, we would just divide the two numbers. Negative 1 divided by 1, 6. You do the same thing. Keep, change, flip. You get negative 6. So there's two different ways to do it. You can either do the operation first, either add, subtract, multiply, or divide first, and then plug in, or plug in and then do the operation.